Hello all, once again, Root Beer here with more hyperbolic, straight edge, and compass constructions. And as I've mentioned in the past, angles are one of the most notably weird things when you do hyperbolic geometry and things like the Poincaré half-disk model. And so I thought I would show you how to do angle bisectors. Now, you probably know how to do angle bisectors because just like everything else we've been doing, it's the exact same construction with straight edge and compass in Euclidean geometry as it will be in hyperbolic geometry. But let's get an angle bisector for this angle right here. Okay, so, well, how do we do it in Euclidean geometry? Get a circle, get intersection points, and then we just use these points to create a perpendicular line. Alright, very quick, not a whole lot to worry about. And we'll clean things up a little bit. So there we go, this new line, which I'll make black for just a moment. This new line is an angle bisector of the given angle between these green lines here. And you might say, well, angles are weird. How do I know it's an angle bisector? Well, again, locally, this thing looks, the angles between these arcs, the angle between these hyperbolic lines, locally, they look like straight lines. They look like the tangent lines. So if we zoom in and zoom in and zoom in, and these guys start to become straight lines, and you can see, I've mentioned in the past the circular arc tool. It's the bane of my existence in GeoGebra. You can see this point, even though it's supposed to be on this line, looks like he's off. That's the circular line, or the circular arc tool at work. But if we zoom out to the point where he still looks like he's on it, we still look like we basically have straight lines, and yeah, this one here has basically cut it in half. So it really is an angle bisector. Okay? And it's the exact same technique we do for the angle bisector using Euclidean straight edge and compass. It doesn't change, and this is one of the things I like. If you have ever read sort of the first little bit of Euclid's Elements, I think the first 20 some odd propositions are true in both regular Euclidean geometry and hyperbolic geometry, where you can have multiple lines parallel to a given line passing through another point. Okay? Some of these things overlap, and some of these constructions overlap. In fact, basically every construction I'm going to do overlaps. It's just about seeing that, hey, it kind of looks different because you're doing curves and lines rather than curves as lines rather than just straight lines that we're used to. Okay, so we'll make another new tool. You've seen how this goes. I might stop showing the creation of the tools. Oops, wrong one. We want the disk, and we'll call this angle bisector. And we have a picture for that right there. So there we're done. New tool is created successfully. I'm just going to move him down because we're not going to be using him. We're still going to be focusing on our straight edge and compass. So we'll move it down to the very bottom, but we still have recreated the tool. There we go. So join me in the next video as we do a little more with straight edge and compass.